So what we need to do first is write down what we are given. So we know that we have 121 grams of both of the reactants. And our end goal is to see how many grams of this can be made. So when I have two things starting here, the first thing I'm going to think of is they've given me two amounts. Then that means I'm going to have to do a limiting reactant solving. So my first thing I do is I'm in grams, and I need to get 2 moles. So I'm going to take each one, and I'm going to divide them by their molar mass. So aluminum gets divided by 27 grams per mole, and the chlorine gets divided by 71 grams per mole. So somebody get me those two numbers. 4.48 for aluminum. 1.70, so we'll say 1.70 moles of chlorine. So can we decide who is limiting? What? No, what did you say?
I was going to say, don't you divide by the coefficient?
Yes, yes, you do. You divide by the coefficient. So each one gets divided by their coefficient. So 4.48 gets divided by 2. So that gives me 2.24. 0.563. And, let's go with that. And this one gets divided by 3. And those are my two things I'm working with. So which one limits us? So this is my limiting reactant, so that is chlorine. So once I've done that, I've found which one is going to take us to get the maximum amount of the, or to limit us. We need to see how much of this we can make. So we go back to right up here, let me see, right up here where we converted it to moles. And we're going to take that and we're going to convert to grams of AlCl3. So now I have 1.70 grams of Cl2 for every 1 mole of Cl2. Or 3 moles, sorry. What? That should say 3. For every 3 moles of Cl2, there are 2 moles of AlCl3. And for every 1 mole of AlCl3, how many grams are there? Let's see, 71 plus 27 plus 35. What? Somebody put that in the calculator. 133. Thank you. 133 grams of AlCl3.
So how did you take 1.7 moles of CO2 and then make it into 1.7 grams?
Oh, sorry. Thank you. That's why I didn't. Thank you. The one thing I need you to recognize too is that everything, all the conversion factors, the molar mass conversion factors, that is always over the same compound. The only time you have 2 different compounds in the same conversion is right here in the mole ratio. So you can't say I've got 5 grams of chlorine over 1 mole of aluminum. You just can't do that. So you've got to recognize that. So what's the amount that we can make? What's the amount of, how many grams of aluminum chloride can we make? Is it 151 or something? I don't know. You need to, so 151 grams of 150.7, so 151. AlCl3. So what we're going to talk about today is theoretical yield. So in the lab, theoretically, that's what I can make. Okay?
Why is it theoretical?
Because in theory, if everything we do in the lab is perfect, that's what we should get. Okay? So everything we've calculated up through today has been theoretical yield. Those are all theoretical. So let's talk about this. So we're going to talk about percent yield. So there's three things being involved with percent yield. So first of all, percent yield is the ratio of actual over theoretical. Well, what's actual, what's theoretical? Well, theoretical, I told you, is what we calculate. That is, on the paper, all the math that we do are theoretical yields. In a perfect world, what are we going to get when we go in and do the lab? And that doesn't always happen. So we have the actual yield. Actual yield is when you go in and you do the experiment, that's what you got. Okay? So what on your lab week after next, what you're going to do is you're going to calculate theoretically what you should get. You're going to go do the experiment and you're going to get your actual yield. And then you're going to see how correct are you. So the percent yield is the ratio of my actual over my theoretical times 100. This equation is located on your formula chart. Over here it says percent yield. You just have to know actual over theoretical, and most of the times you'll put it in the calculator wrong, and you'll get a number that's greater than 100%. The only time you should get a number greater than 100% or you should never get a yield over 100% in the lab. If you do, then you've contaminated something. Okay? So you need to go back if your answer comes up to be over 100% and see if you put it in the calculator wrong, because most likely that's where it's going to happen. So actual over theoretical. This is, I think, question number 20 on your homework. It was the fill in the blanks. Questions over that? So there's two ways problems I can give we can talk about percent yield. I can say, like we just did the last problem. On that last problem, we determined the theoretical yield, which was 151 grams. And I could say, hey, you went into the lab and you got 140 grams. What's your percent yield? Okay, so I can give you the theoretical, I can give you your actual, and then you can solve. Or, like you'll see in your homework, you are going to be required to go find out what your theoretical is after being given what you actually got in the lab, and then solve for that. So lots of ways that this can be asked of you. I can say, hey, your percent yield was 86%, and theoretically, your theoretical yield was this. What was your actual yield? So I can ask you for any one of these variables, this one, or this one. If you don't know how to solve for that, then you need to go refresh your algebra. So again, actual is what's measured in lab. Theoretical is on paper. Now, we're doing these problems. I'm not actually going to say, go in the lab and get this. It'll tell you, in the lab, you got this, or whatever. So we will give you the actual on a test or in a worksheet or whatever. If I can say whatever one more time. All right. Everybody good?
Yes, whatever.
Did he just say whatever?
0.
A prank? I am recording.
Good.
Okay, so here is one of those ones where it's a big, long problem, a process. So the very first thing is you are given 45.8 grams of K2CO3, and it reacts in excess of HCl. So I know HCl is not going to be very important to me. And we get KCl, 46.3 grams of KCl, so water doesn't mean anything. So this tells me that this is what we got when we went to the lab. So what is that? What does that represent? The actual yield. So I have my equation down here. And I am going to just go ahead and put my actual yield in there. So 46.3. Now for me to get to my percent yield, I need to go find my theoretical. So on paper, what should we get in the lab if I am given 45.8 grams? So we have 45.8 grams. And we need to take that to grams of KCl. Okay, so our next step. Start with what we're given. We are given 45.8 grams of K2CO3. What's our next step? Molar mass of K2CO3. So let's go find that. 39 times 2 plus 12 plus 48. 138? 138 grams of K2CO3. And that is always in 1 mole of K2CO3. Now, what's our next step? Mole ratio. And it's always unknown over the known. And our final step. Molar mass. So K is 39.1. Chlorine is 35.5, 74.6, and that is for 1 mole. Now, solve that for me. $49.5 grams of KCl. So theoretically, in a perfect world, if everything went correct, we should get 49.5 grams of KCl. So I'm going to put that down here in my equation and solve for that and tell me what is our percent yield. 93.5%? Good. I would say anything above 90% is good. When you start, you go to college and you get labs like this, choosing your lab partner is, can be really important because you don't want to have a lab partner that is very klutzy or whatever, and because if your grade is based on this, then you want to make sure that your lab partner and you are very methodical in what you're doing. That's why I said, and here I make you justify why did you get 50% yield? What went wrong? If this is over 100%, say this was like 49.9 or something, which gets me this over 100%. Then you've contaminated something wrong, contaminated it with something, or you may have not let it dry all the way and you still have water on that sample.
So if it's over 100 is bad?
Over 100 is bad, yes.
Under 90 something is bad?
Under 90 is bad, yes.
So it has to
How do you
be.
get those numbers in the lab?
How do you get those numbers in a lab? Well, we're going to do that. So I'm going to give you 2 compounds. You're going to take them. It's going to be 2 solutions, and you're going to get a solid, and you're going to take that solid and see what your theoretical yield should be. And then you're going to take that solid and filter out all the liquid and just get the plain solid and tell me what your actual is. So it's a lot of filtrations, that type of stuff. Any questions on that? So this is one of those ones where it would be, it's a 2-stepper. You've got to tell me what the theoretical is, and then you've got to tell me what your percent yield is. So the next one says sodium reacts with chlorine to produce salt. If the theoretical yield, so right here is my theoretical, and is 54.2, and the actual yield is 31, calculate the percent yield. So this is one of those easy ones where it's percent yield is going to be equal to our actual over our theoretical times 100. Let me grab you one of these sheets. So our actual is 31.0. Our theoretical is 54.2. And we multiply that by 100. Did you? Well, it's more practice for you, so take a picture of that so you have it. Actual, so we have 31, 54.2. What's my percent? 57? 57% is our yield. Yeah, we probably should. I'm just doing dirty math right now. So one of the things, too, is you might get a professor that goes, oh, your yield is based on, or your grade is based on your yield. So if you got a professor that says your yield was only 57%, so it depends on your professor and how they're grading.
Wait, but then what if the thing is, like, doesn't that mean if it's already low enough and you're going to get that grade?
Huh?
Like, if that's already low, you're going to get that grade no matter what?
So you never know. It's their classroom. They can do whatever they want. Maybe, maybe not. All right, so last problem. When I was a sophomore in college, we had a lab where we were supposed to isolate caffeine from tea leaves. Most of my caffeine was washed down the drain in a freak accident. Although I should have had 5 grams of caffeine. So there's one of my numbers. No. Dang, I can't even make a circle. 5 grams of caffeine. I ended up with 1.04 grams. What is my percent yield? And a bad grade. So percent yield is 1.40 over 5. What is it? 28. 28%. This is my last slide. So, like I said, I could have said my yield was 28%, and I should have gotten 5 grams. What did I actually get in the lab? So you would have to solve for this. So, those are things, you'll see that on your homework tonight. Homework answers have been uploaded. Any other questions before I give you your assignment?
Is this stuff going to be on the quiz?
No. What's on the quiz is through mass to mass. Okay? All right, so let me stop this and